Right. It says compounds are classified into families that are called homologous series. Right. Each homologous series has a functional group that determines the physical and the chemical property. Right. So these organic chemistry compounds, they're classified into what, into homologous series. Right. And also these homologous series have what, they have functional groups that determine their what, their physical and their chemical properties, guys. And then it says a functional group is a type of bond or atom or group of atoms in a molecule that determine the chemical and the physical properties. Right. This just reemphasizes the previous point that without the functional group, we wouldn't be able to tell which homologous series we are in, and also the key properties of a homologous series are determined by what, by the functional group, which means your boiling point, your melting point, and your other physical properties like vapor pressure and viscosity. They're mostly determined by what? They're mostly determined by your functional groups, guys. And then it says a homologous series is a group of compounds that have the same functional group and will therefore be determined by the same general formula, right? So this means that all homologous series that have the same general formula, they have what? They have the same what? They have the same functional group, right? So they are grouped together into the same group, and then they are said by what? By the same functional group, and they have what? Similar properties. Because if they have the same functional group, meaning that they'll have similar chemical and physical properties, guys. So yeah, that's it. Mm. Right. So it then says saturated and unsaturated compounds. So we're then classifying what these compounds, where they're saturated and they're saturated. And then it says saturated and unsaturated compounds so we're dealing with what, you're dealing with hydrocarbons, right? So this is hydrocarbons are what, are consisting of hydrogen and carbon atoms only, right? So hydrocarbons are what, are consisting of what, of hydrogen and carbon atoms only. So there isn't any other compound or element, any other compounds that are found where in the hydrocarbons. It's only the carbon and the hydrogen atom. So it says saturated compounds are compounds in which there are no multiple bonds between the C atoms in their hydrocarbon chain, right? So meaning that there aren't any multiple bonds within the between the what, between the carbon atoms. It's only saturated bonds, or meaning there's only one bond between the what, the C atom, between the C atoms, right? And then it says unsaturated compounds are compounds with multiple bonds between the C atoms and their hydrocarbons, meaning that between the carbon atoms we find that the carbon between the carbon atoms, they are what, they are either double bonds or triple bonds between the carbon atoms. So meaning that these compounds are what, they are unsaturated, guys. So then it says in saturated hydrocarbons, the carbon atom has a maximum of four hydrogen bonds, and these saturated hydrocarbons are very stable and do not and they do not what, they do not react easily, right? These carbon they do not what, they do not react easily, and they are also stable and do not react easily, guys. So meaning that in the saturated hydrocarbons, since we know that the carbon atom has what, has four maximum of bonds, meaning that those four hydrogen bonds, they all fill in the what, they all fill the carbon atom bonds, right? So what they're trying to say is that all the carbon atoms, in all the carbons, you find that there's a maximum of four hydrogen atom, which satisfies the maximum number of bonds that will be found in the carbon atom, guys. Right. Mm, and then it says unsaturated hydrocarbons are double or triple bonds that can be broken. Could be broken, and more atoms can bond with multiple molecules, right? So meaning that the double bond that you find in unsaturated hydrocarbons can be broken down, right? So that the compound can be saturated, meaning that it's not as stable as what, it's not as stable as saturated hydrocarbons, which has the maximum of four carbon atoms. And then it says the term name of different homologous series in hydrocarbons is determined by the number of carbon atoms in the longest chain. So meaning that for you to be able to write the UPEG naming, you need to be able to what, to count how many carbon atoms are in the longest chain. So that forms what, that forms the root name of the what, of naming the compound, right? So yeah, guys, when you're doing a Hupek name, the very first thing that you do is to count your what, is to count how many hydrocarbons you have, is to count how many carbon atoms you have in the longest chain, right? So that forms what, that forms the basis of your naming, basically. And then it says alkanes are saturated hydrocarbons that have single bonds between the C atoms, right? So as we've said that alkanes are what they are saturated hydrocarbons that have a maximum of 4 hydrogen atoms bonded to the what to the carbon atom, right? And these what and these alkanes hydrocarbons they went with a suffix that is A, which is ANE, right? You find that it's butane, pentane, and all that. So that's how they are named basically. So we go to general properties and uses. Then it says alkanes are generally used as what? As fuels, guys, in chemical industry. And then it says alkane consists of symmetrical non-polar molecules and do not dissolve in polar molecules and acids. Right. So meaning that this has what? In this type of compound there is what? There is no there's equal sharing of bonds, guys. There's equal sharing of bonds. There's equal sharing of what of electrons. Equal sharing. Right. So I mean, if there's equal sharing of what of electrons, meaning that there is no net charge within the what in the compound. Right. So yeah, that's what that's what non-polar molecule means. Right. So there's an equal sharing of electrons between the carbon atoms of this compound. Right. And it says it reacts with what? It does not react with polar molecules. Right. So when we go to the physical properties, we dive deep in this content too. What are non-polar molecules? What are polar molecules? You see, and which one dissolve in what? You see, which also would enlighten us into explaining why other things like for example why water rises in a beaker and all that stuff, right? Why is it that when you pour oil in the water in water, oil rises, you see? So those are the concepts that you're going to be focusing on basically, because as it says here, alkanes are what? They are non-polar molecules, and since they are non-polar molecules, they do not dissolve in what? In polar molecules, right? So and also we're given that in earlier on that what that hydrocarbons are mostly what? They are mostly fuels, right? So meaning that when if they are fuels, they contain non-polar bonds, right? If they have non-polar bonds, they do not dissolve in polar bonds, meaning that they will rise, or there's gonna be a distinction between polar molecules and non-polar molecules. Whether you mix them or not, they can never stick to each other. And then you go, it says that alkanes are less reactive than other homologous series, right? Single bonds are more stable than double bond or triple bonds, therefore they are harder to break. Yeah, as said before that um the carbon atom that has alkanes, or that is an alkane compound, it has a maximum of what? It has a maximum of 4 hydrogen atoms that are bonded to the what? To the carbon atom, meaning that there isn't a space for this compound to easily react to other compounds because it has already been filled. And then there's an equal sharing of what? Of these of electrons between the what? Between the carbon atom and the hydrogen atom. There isn't a net charge in the what? In the compound. That's why they're saying that they cannot react easily. You understand? And then it goes on and says it says due to their symmetry, they do not have areas with excess or shortage of electrons where a reaction could take place, right? This just re-emphasizes the above point that says that alkanes are stable, right? So if they are stable, meaning that they don't react easily because of what? Because there is maximum bonds within the carbon atom. Because you know that the C atom has what? Has it can make a maximum of 4 bonds. So now if those 4 bonds are already filled, then it means that it will not have another space to react with other compounds, basically, right? So yeah, that's it. It says with an increase in the length of alkane chain molecular mass, their physical properties, including melting and boiling points and vapor pressure changes. Right. So we're gonna go dive deep into more details into this in when we're dealing with what physical properties, right? Which will be the next video. Right. So physical properties play a vital role into us understanding the concept of what of organic chemistry, and it explains a lot of things that we wouldn't know. It explains a lot of concepts basically, right? Like the previous example that I made of non-polar molecules unable to dissolve in polar molecules, right? It says it explains all those things which are which are the physical properties, right? So yeah, guys, we're gonna dive that deep into the physical properties of organic chemistry. So we're gonna dealing with the molecular mass, the chain, how does an increase in the chain of what of an alkane affect the physical property of the compound? How does the molecular mass affect the physical property? And also within the physical properties, what are the melting points and the boiling points, and how are they related to the functional groups basically? So we're gonna dive deep into this concept, guys, on our next video, because it's part of the curriculum which you are supposed to know. Yeah, guys. So basically, all you can see here is what is the first 10 what? These are the first 10 alkanes that you're supposed to know. Because without you knowing this concept, you won't be able to what? To understand it firstly, and secondly, you won't be able to deal with the what? You won't be able to deal or to deal with the UPEG naming. When you say write a UPEG name of the compound, you won't be able to write it because you do not understand the root name. So meaning that you need to memorize these from the compound that has one carbon atom to a compound that has 10 carbon atoms, right? So basically, it's what? It's methane, ethane, propane, butane, and all that, guys, on all that. So you're supposed to understand and know this concept, guys, because it's examinable. So it says now we're dealing with alkenes and alkynes, guys, which are what? Which these are the compounds, they're hydrocarbons that are what? That are unsaturated, right? So what did I say about unsaturated compounds? So these are compounds that have what? That have either alkenes in this example, which is alkenes in this example. These are what? These are hydrocarbons that are what? That are unsaturated, for example. And these have what? These have double bonds, guys. Double bonds, right? And then we have what? We have alkynes, right? So these chemical compounds, they have what? They have triple bonds. This one, they have triple bonds, guys. But we're gonna go into much more content, like we're gonna distinguish them as we go in the video, right? So the first line it says that alkene are hydrocarbons that are indicated by the minimum of one double bond between the C atoms. So meaning that there needs to be a minimum of what? Of one double bond between the carbon atoms for us to be able to classify that compound as what is an alkene compound, right? So it says whereas the alkynes are more represented by triple bonds between the C atoms, right? So meaning that as stipulated above that, alkenes and alkynes, these are what? These are unsaturated compounds. With one which has double bonds between the carbon atoms, and the other one has what? They have triple bonds between the carbon compounds, guys. And then it says when you name an alkene or alkyne, you number the longest C atom on the what? From the side of the double bond. So meaning that when you name these type of compounds, you start counting from the what? From the side that is closest to the double bond. Right. So let's say if the double bond we have, let's make an example. So let me make an example. Let's say we have one, two. Mm, so this is what? There's a double bond here. No, there's no double bond here. Let me just start over. Yeah. So let me make an example. It's one, two, and then the double bond. Right. So we see from this above example we have what? We have one, two, three, four, five. Right. So this is what? This is supposed to be pen change something. Right. Because there's what? There's five what? There's five carbon compounds. Right. So meaning that it says when you name an alkene or alkyne, you number the longest carbon atom from the side of the double bond. Meaning that you start counting when you pick naming from where? From the side that is closest to the what? To the double bond. Right. So meaning that if you start from the right, so one, two, three, right? It's on the third carbon atom that there's gonna be a double bond. Right. So meaning that you need to start where closest to the double bond, guys. It's one, two. So meaning that you need to start from the left. This is gonna be our first. It's gonna be our second carbon atom, our third, and our fourth, and this is the fifth carbon atom. So you start counting from this side, guys. You start counting from the closest to where? To the double bond, right? And these double bonds, guys, they represent what? They represent the functional group of the what? Of the compound, basically, right? So yeah, either it's gonna be an alkene or alkyne, but it needs to be closest to the carbon atom that has a double bond, right? So yeah. And then it says the double bond and triple bond forms the functional group, right? So these double bonds and triple bonds within these unsaturated hydrocarbons, they form what? They form a functional group of the compound, right? Because we know that there's alkenes, and alkenes are what? Are double bonds, right? How is alkenes different from alkanes? They are different from them by the what? By the double bond, right? And also the what? The chemical properties of these two homologous series will differ from each other because they are what? They have different functional groups, right? So yeah, this all guys connect together. This all connects together. As long as you understand the what, as long as you understand that hydrocarbons are what, as long as you understand that you start naming from where, from the carbon compound that is closest to the functional group, right? And also being that said, you need to understand that these double bonds and triple bonds within these unsaturated hydrocarbons, they form the functional group of the atom, right? So yeah, guys, that's what you need to know basically. And then it says alkenes or alkynes, multiple bonds can break during reactions when the more saturated molecules are formed as the product, right? So basically, we're gonna dive deep. I'm gonna dive more deeper into this content on our second video where we are looking at the physical properties, right? Because these double bonds, as we illustrated in our previous slide, is that these double bonds can what they can break to form saturated compounds, right? Because they are unstable basically, right? They are most unstable compounds that can react easily with other compounds, unlike alkane that has the maximum of four hydrogen bonds within the carbon atom, right? So basically, guys, this is it. All you need to know this is, if you understand this content, then basically in terms of alkenes and alkynes, you'll be able to maneuver within your questions, and to be able to understand the content into a much more clarified or deeper or deeper knowledge, right? And then yeah, guys, let me erase this. So basically, this is the illustration of alkanes and alkynes. As you see here, these are what as you see in this illustration. As you see in this illustration, guys, as you see in this illustration, these are alkanes basically, right? There are no multiple bonds between the C atoms, right? There are no multiple bonds between the carbon atom, guys, right? Whereas in this side is alkanes, right? They are classified by what? They are classified by the double bonds, right? You see, there's a double bond between There's a double bond between the C atom, this carbon atom, and this carbon atom. There's a double bond, and then we have what? And then we have our third compound, which is ethene, right? It has ethine basically. It has what? It has triple bonds between the C atoms, guys. Right. So you need to just understand this concept, and you need to understand that alkenes and alkynes and alkanes are what? These are hydrocarbons. Why are they hydrocarbons? They are hydrocarbons because there's only a hydrogen bond between between the carbon atom. There aren't any bonds, like for example the hydroxyl group or anything of that sort, or maybe oxygen, or anything of that sort. It's only hydrogen and carbon. Right. So yeah, be that it may be, this is easy as this, guys. There's nothing like that super skyrocketing or anything. Yeah. So it says alkanes with more than one double bonds are known as dienes and trienes, right? Alkynes with more than one okay. So it says alkanes with more than one double bond are known as dienes, and then with three double bonds they are known as what? As trienes, right? So this is that, as you've said before, that there can be more than one double bond in the what in the compound. So meaning that if it's there's two double bonds, you need to illustrate that in your UPEC naming, that in this compound there's two double bonds by putting die in when the what is the as the prefix of your naming, right? It's die in illustrate no that there's two double bonds. And then if for example there's two bonds, you represent by what? By die in, guys, by die in. And then if there's triple bonds, you represent by what? By try in. Nothing that's so fascinating. It's just you just only have to understand that. And then it says alkynes with more than one triple bond are known as dienes. Alright. So it's the same scenario as in the above point, that if you have more than one double bond, for example you have two double bonds and the triple bonds, you need to illustrate to your marker. Know that in this compound there's two double bonds by two triple bonds by putting what? By putting diene. Diene is this what is the suffix, right? If there's triple bonds, you put triene as a what? As the suffix, guys. You see. So yeah, that's easy as that. That's easy as that. So yeah, guys, this is the illustration that you need to know here. This is illustration that you need to know, right? You see that is what is 1 2 3 4. Now you need to indicate that it's but 1 2 die in, because on the first carbon atom and in the second carbon atom, right? There's a double bond. And also, as we said, or was it in our previous slide, that you start counting from the carbon atom that is closest to the functional group, right? And the double bonds in this example serves as what is the functional group, right? So you need to start counting from the right. You need to start counting from the right, guys. So yeah, that's how easy it is. So yeah, guys, these are the illustrations that you need to understand. You need to know the whatever homologous says, or whatever compound that you are in. You need to know you need to be able to know the functional group. You need to know the suffix and the prefix. because this knowledge is very important in naming what and naming the UPEC naming of the compound, and this is examinable, right? So you need to understand that in alkanes there's what alkanes it's single bonds they end with A, in alkanes it's triple bonds that end with E, and all that, guys, right? This is just content that you just need to memorize, but you don't need to memorize it because as soon as you start doing the questions, you understand it much further. You understand it much further, guys. So yeah, basically, that's how easy it is. So yeah, this is our second illustration. Yeah, you just have to study this, and after studying this, and then you understand it, and then you're good to go. Right. So guys, I'm gonna try to include the link of these notes in the description below. Right. If you say, for example, you want these notes, you can comment in the comment section, and then I'm gonna leave them, guys. I'm gonna leave these notes because I understand some maybe you don't have sufficient notes as these, and these notes summarize everything. Right. So yeah, guys, if you want these notes, you can just comment below. I'm gonna issue you the link. You see. So right. Uh, all these homologous series compounds, they have what they have general formula, right? All the alkanes and alkynes, they have a general formula that you can what that you can understand, that you can use to be able to what to write its molecular formula, because we have what we can represent our hydrocarbons in three ways. Not in three ways. We can represent them in what in as structural formulas. We can represent them as what we can represent them as semi-structural formulas, and also we can represent them as what as molecular formulas, right? So for you to be able to write the molecular formula of of these hydrocarbons, you need to understand the what you need to understand their general formula first, right? You need to understand their general formula. For example, for alkanes, for you to be able to name an alkane, you need to know how many carbon atoms there are there, right? Then if you know the number of carbon atoms, then you're good to go, right? You just in the space of the on the subscript, right? So in this subscript here it's Cn, right? So in that place of n, that n represents what? That n represents the number of carbon atoms that are there, right? So the same thing for H, you put 2, and then you put n, which is n, the number of what of carbon atoms. If let's say we have 5, can you say 3? Let's say we have 3 carbon atoms, right? So it's gonna be what? It's gonna be C3 H what H 2, and then in a place of n you put 3 plus 2, right? So it's gonna be what? It's gonna be C3 H what H8, right? So let's count. Let's say it's 1 2 3 4 5 6 7 8, right? So there'd be what there'd be 8 hydrogen atoms, right? So for you to eliminate you counting these hydrogen atoms on a singular basis, you need to what you just need to understand that where there's an n, you put what you put the number of the carbon atoms. The only thing you need to count is the number of carbon atoms, and then you're good to go. And it goes the same applies for alkenes and alkynes. Nothing changes. As long as you know the number of carbon atoms that are there, you can be able to what you manipulate the molecular formula of the compound. That's how easy it is. So these are what these are basically the examples here of alkanes here, alkanes, and then we have what you have alkene, and then we have alkyne, right? So on the South African curriculum, which is known as CAPS, the only topics that they examine it's alkanes and alkynes. The Umarus does not look at cycloalkanes, guys. You don't need to know this content. The cycloalkanes are not that important, right? You're only focusing on what alkanes and alkynes in terms of hydrocarbons, right? Yeah, this is another illustration, right? Just focus on the alkanes and alkynes, and then you're gonna be good to go. So yeah, guys, if you've reached this part of the video, please consider subscribing to my channel, right? The subscription button, if you do not know it, it's on the bottom right of the screen, right? In the bottom right of the screen, it's that red squarish button. You can click there, and then you can subscribe to my channel so that you won't miss any video that I do in the future, right? It also helps into making my videos to be viral to the students that are doing the same content as you're doing, right? So not only are you helping me to grow the channel, but also you are assisting students that are not familiar with the channel yet to be able to see the channel on their screens also. So by subscribing, you're not assisting me, you are making science to be more fun, to be more accessible to other students who are needing the same assistance as you do, guys. So yeah, guys, please subscribe to my channel, and yeah, please follow. click the notification bell also so that you can be notified every time I post a video, right? So let's go to the content again. It says haloalkanes and alkynes halides basically. So basically it says haloalkanes are just alkanes that have lost a hydrogen bond and they have been what replaced by what a halogen atom, which is can be fluorine, it can be chlorine, it can be bromine, it can be iodine basically, right? So haloalkanes, these are what? These are hydrocarbons that have a hydrogen atom that has been replaced by what? By fluorine, chlorine, iodine, or bromine and iodine, basically. The quick example that I can make is that, let's say, for example, we have one, two, three, right? So instead of having instead of having eight carbon atoms, we can have what? A fluorine that sticks to what? That sticks to that bonds to the carbon atom, and then we have other hydrogen atoms that are bonding to it, right? So basically, you only need to what? Only need to see what a hydrogen what halide, right? You only need to see a hydrogen halide to see that okay, this is what this is an haloalkane. It's that simple, right? There's nothing that's super yeah. It's only understanding that it's what it is. There's a replacement of, or instead of being a hydrogen, there's a halide that is being added to the what to the compound. So that's how easily it is, guys. And then it goes on and says, haloalkanes are used in household products, right? So this is not examinable. Basically, this is just extra information for you to be able to know, right? This is not examinable. It's just fun facts that you need to know, guys, right? Because maybe you're gonna do organic chemistry, maybe you're gonna follow the chemistry field in uni or maybe in college. So yeah, these are the things you need to know, maybe to broaden your understanding of the content, basically, right? The only thing you need to know about haloalkanes is that instead of an hydrogen that is bound on the carbon atom, it has been replaced by what? By a halogen atom, basically. So yeah, that's it, guys. Let me erase this. Right. So on the left hand side we have what? We have an example of what? Of an haloalkane, basically. Right. So also when naming an haloalkane in terms of your pick naming, you need to indicate to your marker that the haloalkane is found on a what carbon atom. Right. As you see in in this illustration, we have what? We have one bromo butane. Right. We have one bromo butane because we have bromine that is attached to what? To the first carbon atom. Bromine, which is a halide, hydrohalide, that is attached to the what? To the first carbon atom. You see. So you need to indicate your marker that this haloalkane is attached to the first what? To the first carbon atom. That's why you say it's one, and then you put a dash bromo butane. Right. I'm gonna go into much content into terms of the UPEG naming because I understand that other students might have a difficulty into this content because if you do not understand UPEG naming, then yeah, you're gonna lose marks because much okay bulk of the content is on UPEG naming and also writing the structural formulas of the compound, right? So if you understand that by on organic chemistry, then it's easy because it's writing the molecular formula, the structural formula, the UPEG name, understanding how to write the UPEG name, and also understanding the physical property, right? So if you understand those four content about this concept of organic chemistry, then you're good to go. There isn't anything that so skyrocketing that you need to understand, basically. So now we're dealing with what? We're dealing with alcohols, guys. It says alcohols can be used in preparation of other compounds as raw materials, right? So it says ethanol. Okay, it just there's other raw materials, right? This is not much more important as of this moment, but it forms what? This will form the pre-knowledge before we go to what? Before we go to the physical properties, right? So yeah, right. It says ethanol is the most used alcohol and is known for its alcoholic beverage consumption, right? So basically, the alcohol that you consume, like your beer, your ciders, are made of what? They are made of ethanol, right? And ethanol is what? We know that it's ethene is what? It's one, two. It's methane, ethane, right? So meaning there's what? There's two what? There's two carbon atoms, right? There's two carbon atoms, right? And also there's what? This is an alcohol. This is ethene, basically, right? So the alcohol that you consume, guys, it's ethanol, right? And it's the most consumable one. Is that it's not dangerous and all that sort, right? And then it says alcohol can form intermolecular bonds with water because they are polar molecules and contain hydrogen bonds. Right? We're gonna go much too deeper into this content because in the in the physical properties, you need to understand what the type of bonds that homologous series have, basically, right? So alcohol is one of the homologous series that has hydrogen bonds, right? So it says alcohols can form intermolecular bonds with water because of the polar molecules and what of the containing hydrogen bonds, right? So this says that if it's a polar molecule, as I've said before, it indicates that what is unequal sharing of what of electrons, right? So it was polar molecules, polar molecules, what polar molecules have unequal sharing of electrons, basically, right? So all polar molecules have unequal sharing of electrons, meaning that there's gonna be an atom that needs the electron much higher than the other atom, right? So this is called electron affinity, right? It's part of the content. Hence, I'm saying that the organic chemistry is a very broad topic and it involves all other content that you've learned so in the previous grades, in the grade 11, grade 10, right? Also, it says that since it's what polar molecules, the electronegativity between these two compounds it's what is not the same. Right? If the electronegativity is not the same, that means that one compound is gonna need this carbon, the electron, much greater than the other than the other carbon atom, right? And than the other than the other molecule, right? So you'd see that by what you'd see this by what you'd see this by by compounds that need that have would say more that have less that have more electrons in their valence shells, right? So as I'm saying that organic chemistry guys ties like to all the content that you've learned, right? So meaning that the compounds that have high electronegativity, these are the compounds that have in their valence shells that have either they're lacking one or two electrons, right? And what is a valence shell basically? Valence shell is that shell in the orbital of a molecule that is at the end, right? So you see when compounds when compounds are bond covalently, they bond with what? They bond with valence shells. They bond with shells that are on the outer side, right? So that means that how a compound wants an electron will depend what it will depend on its valence shell basically, right? If the compound needs it more, that electron it needs more of the electron, it will get more attached to electron, it will draw the electron to its to closer to its nucleus basically, right? Than an atom that for example has one electron in the outer shell, right? If an atom has one electron in the outer shell, it won't need the electron as much as an electron it won't need the electron as much as an atom that has more and needs one than the one that has one, and it needs to sacrifice that one basically. I'm not sure if I'm making sense, right? Yeah, I'm not sure if I'm making sense, but all that is that the valence shell is the what is where you look at it's where you look at the compound basically, right? Of whether does it need the electron more or does it need it less, right? If it needs it more, you'd see that by the valence shell, this compound is gonna need one or two electrons for it to be filled, right? So this is I'm diving too much more deeper content and it's gonna take long. Gonna make the video long. But anyway, guys, I'm gonna need to cover this content into another video, right? I'm gonna need to cover this content into another video. Basically, yeah, that's it. There's valence shells and all the electronegativity, right? So this means that if a compound needs an electron much more, it will have it will have maybe one or two electrons that it needs in the valence shells for it to be filled, right? So meaning that there's gonna be unequal sharing of electrons between these two atoms, right? So if there's unequal sharing of electrons or between these two atoms, the net pole of the compound is going to have a charge basically, right? So if it has a charge, then we're going to call that compound what? We're going to call that compound a polar compound basically. So that's what happens in a water molecule. That's what happens in a water molecule. You'll find that there's what? There's gonna be an oxygen atom, and then there's what? There's gonna be what? These two hydrogen bonds, right? These two hydrogen bonds. You see, these hydrogen bonds have what? They have one electron in the outer shell, in the valence shell, right? They don't need the electrons. They just want to get rid of it so that they can be what? They can be full, or they can be stable, right? They don't need the electron. These hydrogen atoms, right? That's why you see that the electron is gonna be drawn too much on the what? On the oxygen atom, right? So if they do not need, if these hydrogen atoms don't need the electrons, this means that this pole is going to be what? This pole is going to be positive, and this pole is going to be what? Positive. And this pole, the oxygen pole is going to be what? It's going to be negative, guys. It's going to be negative because the electrons are going to be drawn too much on the what? They're going to be drawn too much on the oxygen atom, on the oxygen nucleus, right? And also this ties to everything that you know, basically, because you understand that the nucleus is what? The nucleus is filled with both protons and neutrons, right? And you know that protons are what? They are positively charged, right? So, guys, yeah, we're going to have to fill this content into another video because it's going to make this video long. So yeah, basically that's it, guys. Polar molecules are what? These are molecules that have what? That have a net charge on their what? On their they have a net charge on their atoms, right? As we see this example here in the water molecule, right? Yeah. And then it says, as the result of the strong hydrogen, as a result of the strong hydrogen intermolecular forces, alcohol have between the hydroxyl molecule, the molecule have a higher boiling and a melting point. Right. So these compounds, these polar molecules, they have what? They have a higher melting and the boiling points. Right. This is just the pre-knowledge now that you need to understand before we go what? Before we go dive deeper into the content of what? Into the content of intermolecular forces and the physical properties of the compound, guys. Basically, you understand. So yeah, basically these are what? These are alcohols. Right. And alcohols are represented by what? These are compounds are represented by what? By the hydroxyl group, guys. This is the hydroxyl group. Right. So instead of what having an hydrogen atom that is attached here, as in this example, let me give an example. Right, this is what this is. Let's say it's one, two. Okay, let me just erase this. So this is one, two. Right. So instead of us having a hydrogen atom that is bonded here, we have a hydroxyl group. A hydroxyl group is a group where there's an oxygen and a hydrogen atom. Oxygen is bonded to the what? To the carbon atom, and there's a hydrogen atom that is bonded to the what? To the oxygen. So this is called the what? A hydroxyl group. Right. So this is how you see what? This is how you see alcohols basically. Right. And this is what? This is ethanol as we illustrated in our previous point. You understand? So these are what? These are alcohols, guys. So you need to understand this content and read because organic chemistry is all about reading, understanding the content for you to be able to pass it basically. You understand? So yeah, that's example of what? Of a hydroxyl group, guys. Is have already underlined here. Right. And this is what? This is ethanol. This is ethanol, people. So yeah, guys. This is the introduction to organic chemistry. Right. We're gonna dive much deeper into this content. So it says during the hydration reaction where water is added to to an unsaturated compound and alcohol is prepared as the byproduct, right? So meaning that when there's because we talked about what we talked about the unsaturated compound being what being saturated, right? Now, when we're transforming unsaturated compound to an unsaturated compound, there's called what? There's a reactions called hydration reactions, where there's addition of water to the molecule, right? So which means the double bonds that are between the between the carbon atom is broken down, and when it's broken down, there are what? There are atoms that are attached to that carbon atom, right? And one of the example of that is hydration, right? We're gonna, as I've said, we're gonna go into this content into a much more easier and much short formatted video, right? So in hydration, which means addition of water to the compound, making it to be more saturated, a byproduct of alcohol is made, basically. Right, this is what this says. It says this hydration reaction needs to take place in the presence of a strongest acid, which is sulfuric acid. Right. So yeah, guys, these things need to happen into what? Into a catalyst that is known as what? This hydration reaction happens in a catalyst that is known as H2SO4, basically sulfuric acid. Right. So yeah, this is what this says, and also this is examinable because when you're doing your what, when you're doing your physical properties, you need to indicate what will be the what will be the condition of the reaction because these reactions, not all these reactions happen spontaneously. There needs to be what? There needs to be a condition that they need to what? They need to have or they need to face, and then the product can form basically. Right. And then it says the ethanol can also be a byproduct of natural fermentation of sugars, carbohydrates, and fruits, guys. Right. So yeah, this what this says, and also yeah, we're gonna go much deeper into the content. If you have any questions about regarding the content, I can easily I'm gonna leave you the link of the of the notes in the description. You just have to say no, I do need the notes, and then I'm gonna leave the link because yeah, I understand that organic chemistry is long and all that. You need more simplified notes than notes that are much more in bulk or doesn't include stuff that you really need to know. You understand? To fruits, yeah. And then it says alcohols are prepared by adding water to an unsaturated alkene, and that is how ethanol is made industrially. So that's how what the beverage alcohol, the ciders we drink, the castle lagers, the savannas, and all the what, um, and all the beverages that we drink. It's all ethanol, guys. It's all ethanol. All the castle lights, all the castle lights, guys. This is what this is ethanol. It says there are three groups of alcohol that are divided according to the number of carbon atoms attached to the hydroxyl group. So basically, what this is this is examinable basically because in an exam they will ask what type of alcohol is this? Is this a what a tertiary alcohol? Is this a primary alcohol? You see, it's all that. But I'm gonna show this into another slide basically. So yeah, basically this is what I mean when they say alcohol are divided into classes, right? So let's start first. Let's start with this type of alcohol. So here we have what? Here we have what? We have a tertiary alcohol, right? Why is it known? Why is it called a tertiary alcohol? It's called a tertiary alcohol because, right? You see, this hydroxyl group is what? It's attached to what? To a carbon atom, and this carbon atom, guys, is attached to what? It's attached to three other hydrocarbon atoms. One, two, three, right? And then it's known as what? As a tertiary alcohol because there's more than two what? There's more than two carbon atoms that are attached to the carbon atom that is attached to the what? To the hydroxyl group, right? I'm not sure whether I'm making sense, right? And then we have what? A secondary alcohol, basically. And this secondary alcohol here basically it's an alcohol where our hydroxyl group is covalently bonded to the carbon atom that is bonded to what? To two carbon atoms, one two, right? One two carbon atoms, right? The carbon that has a functional group basically, which is the hydroxyl group, is attached to two carbon atoms, right? And it's called the what? A secondary alcohol, right? And then we have a primary alcohol, guys. We have a primary alcohol. And the primary alcohol is an alcohol that has what? That is attached to a carbon atom that is attached to one other carbon atom, right? Basically, what I mean is that this is the carbon atom that is attached to the functional group. The carbon atom that has a functional group that is attached to what? To one carbon atom. Basically, this is what? One, only one. So the one with the functional group is attached to what? To one carbon atom. This is known as what? As a primary alcohol. So guys, it's not that hard. It's easy basically. Just need to understand the content, and then you're good to go. And then we're dealing with what? We're dealing with aldehydes. We're dealing with aldehydes. What do you know about aldehydes? So aldehydes says these compounds contain the formal group, which is the carbonyl group with at least, and this is what this is a carbonyl group with at least one hydrogen atom on the same C on the same hydrocarbon on the same carbon aldehyde and the same carbonyl aldehyde formed during the what oxidation. Yeah. So guys, what this means is that it says it's what is a carbonyl group with at least one hydrogen atom on the what on the same carbon, right? And it says aldehyde are formed during oxidation reactions of alcohol. Right, you're gonna dive deep into this content when we're dealing with what? When we're dealing with all the physical properties, basically. Right. So yeah, it says then aldehyde is a what? Basically, all you need to know that they are always a what at the end of the compound. It's one, two, three. Right. The carbonyl groups are always at the end. Right. It's either at the beginning or the end, whatever you name it. Right. This is a what? This is an aldehyde, basically. Right. So they're always at the end, and yeah, that's the only thing you need to know. And then they end it with that. They end with the suffix NAL, basically. But I'm sure I'm gonna show you in presentation. Yeah, this is it. This is a what? This is a hydrogen atom, guys. You can't see it because there's my face there. So yeah, this is a what? This is a carbonyl group, basically. A carbonyl group, usually at the end, basically, or at the beginning. Yeah. So there's nothing much to them. So would you need this would be what? This would be methanol. Methanol, what I'm writing. This is methanol. And then it's either methanol or butanol or propanol because the functional groups always in the end, and they end with what? They always end with what? NaL. And then ketone, it says ketones have a carbonyl group, but on each side of the carbonyl group there is a carbon atom, right? And it says ketone are formed during oxidation of secondary alcohol. We're gonna cover this into much more deeper content in the what? In the physical properties when we're doing the video for the physical properties, basically, right? So yeah, ketones, instead of them the carbonyl group being in the end, find that the carbonyl group is between carbon atoms, right? So this is an oxygen. This is the double bond between oxygen and the carbon atom, right? So that being said, the ketones are always between carbon atoms. Always the functional group is between carbon atoms. Always doesn't change, right? And also their suffix is own. They're always own. For example, let me make an example. Here, this would be what? This would be propane. This would be propane two. This would be propanone. I'm lying. This would be proper noun. This would be proper noun. It would start indicating, the functional group where you have what? When you have more than what? More than three carbon atoms. The moment you have four carbon atoms, they don't need to indicate where is the what? Where is the carbonyl group attached to? And then you need to show it. But in this example, this is just proper noun because it wouldn't be a ketone without these two carbon atoms, without these two carbon atoms here. Right. So that's why you say it's one name. It's only one name. Is what is proper noun. And then we're dealing with what? Carboxylic acid, guys. We're dealing with what? Carboxylic acids, right? So yeah, we are almost done with it. We are almost at the end of our content. So it says the functional group, or is the what? Is the carboxyl group, right? And then it says carboxylic acids are prepared by oxidation of an aldehyde by a strong oxidizing agent, basically, right? Carboxylic acids. Let me make an example. It's 1, 2, 3. Right. So yeah, guys, I'll make an example for you. So this is what? This is a carboxylic acid. So this is what? This is a carboxyl group, guys. This is a what? This is a carboxyl group. Right. So yeah, that's all you need to know. In the carboxyl group is a combination of the what? Of the carbonyl group, right? And the what? And also alcohol. And that's why in hydroxyl group basically. It's carbonyl group and hydroxyl group. That is why they say in this example, a carboxylic acid are prepared by the oxidation of an aldehyde by a strong oxidizing agent, right? And you know that this is an aldehyde. Why? Because this was an aldehyde. Why? Because on the what? On the last carbon atom, there's what? There is a carbonyl group, right? So if then after there's a carbonyl group, there's been an attachment where the hydrogen that was supposed to be here, the hydrogen that was supposed to be here is removed, and the hydroxyl group is added, right? So yeah, this is called the what? A carboxylic acid, guys. You're gonna cover this content on the physical properties, but this is how you say carboxylic acid. And when we were to name this, we would name it what? And this is propanoic acid. Propanoic acid, basically. Right. This is propanoic acid. That in carboxylic acids, guys, you do not indicate any double bond. You do not I mean like you do not indicate any functional group representation space. For example, like alcohols, let's say it's what do I mean? It's 1, 2, 3. Right. Then there's what? Then there's a what? Right thinking here. Right. This would be what? This is will be propane one all. Right. If you name this is gonna be propane one all. Right. But now, in terms of carboxylic, because since all carboxylic acids have a functional group in the end, like aldehydes, you're just gonna look at the what? You're gonna look at the longest carbon chain, which is your root your root structure or your root chain, right? Then it says propan, and then you probably count how many carbon atoms. 1, 2, 3. Then it's propanoic acid, and then that's it. Either if it is gonna be four carbon atoms, it's gonna be butanoic acid. If there's five, it's gonna be pentanoic acid. Nothing serious, guys. Nothing serious. Just have to know this simple content, right? So this is a carboxylic acid. Yeah, example of it. And guys, you go to esters, right? It says esters are formed when carboxylic acid is heated together with an alcohol in the presence of a water catalyst, usually sulfuric acid, right? Sulfuric acid's molecular formula is what? H2SO4, right? So they are heated in what? In a strong presence of a catalyst, which is what? Carboxylic, which is what? Sulfuric acid, right? And then it said water is formed during the reaction as the byproduct. So meaning that there's gonna be a byproduct that is gonna be water, right? I'm gonna do this content into what? Into physical properties because this is called esterification basically. It's one of the reactions that I need to do on the physical properties. It's esterification, right? So here there's what? There's a carboxylic acid basically, which is carboxylic acid plus what? Plus an alcohol basically, right? So yeah, guys, I'm gonna cover this into much deeper content, but esters you need to know that the reaction between what? Carboxylic acid plus what? Plus alcohols. I need to know the byproduct is what? It's water plus what? Plus an ester, basically, right? So yeah, that's how easy it is. But I'm gonna do more reactions into the physical properties, guys. Yeah, guys. Let me erase this so you can see. So yeah, guys, this is a basic representation, as I've said before, of how esters are written. Because you see that this site is what? There's a carbonyl group from where? There's a carbonyl group from the thinking, from the carboxylic acid, right? Then we have an O from the alcohol side, O from the alcohol side, and then they merge or they react together to form what? To form an ester, right? And these are known as what? Ethyl propanoid, right? So the carbon side, or the carbon chain is the what? Is the substituent chain. This chain here is ethyl 1 2 3 what? Propanoid 1 2 3. So this is the what? This is the parent chain basically, and this serves what? Is this serves as a substituent or maybe a branch chain. You see. So yeah, guys, I'm gonna cover this too much more content. This video is getting too long. But anyway, guys, I'm happy that you covered most of the stuff that you need to know for organic chemistry, and it's an introduction basically. So if you understand this content into much more deeper, or understand this content much easier, then yeah, organic chemistry won't be that hard for you basically. You see.